The next example tells us we have to use vector methods to prove that the line segment joining the midpoints of two sides of a triangle is parallel to the third side and half its length. So there's two things I have to make sure I prove. Conveniently, I can prove them both at once using vectors. First, let's draw the diagram. Our triangle, it doesn't tell me anything about the triangle, so it's best if you can draw yourself a scalene triangle. That actually looks a little bit isosceles. I should have tried harder to make it scalene. The idea is to stop yourself assuming things that aren't true. So let's call it A, B, C. So I need a line segment joining midpoints of two sides. So here's a midpoint. Let's call it D. And here's a midpoint. Let's call it E. And let's put a line segment joining it. Looks like it could be parallel, doesn't it? So my job is to show that DE is parallel to AC and is half the length of AC. Well, have a think about this. If I'm going to get from A to C, one way to do so is to go via B. AB plus BC. Okay, why do I do that? Because I'm going to use it to get this bit here. DE now, to go from D to E, again I'm going to go via the same point B. DB plus BE. Okay, DE is D to B plus B to E. But wait, D is the halfway point between A and B, which means DB is half of AB. Half of AB. And BE, E is the midpoint of BC, so BE is half of BC. Now maybe you can see where we're going. These are scalar multiples. I can put them outside a bracket. AB plus BC. But wait a minute. AB plus BC is AC. Half of AC. So, with one statement that DE the vector is half of AC the vector, that means that DB is parallel to AC, and it means that the length of DB is equal to half the length of AC. And I've proven what I need to prove. And you know, because I know you probably like doing so, you can then go QED because I've proven what I need to.